Hi everyone. In this lesson we're going to learn about the properties of a rhombus, and then we're going to use them to solve problems. One thing, the plural word for rhombus is rhombi. So if you're referring to more than one figure, they will be called rhombi. A rhombus is a parallelogram with two congruent consecutive sides. Consecutive means those sides that are one next to the other. So for example, PQ would be consecutive to QR, and RS would be consecutive to QR, and so on. So this is a parallelogram by definition, but it's a parallelogram with this special condition that two consecutive sides are congruent. So for example, PQ would be congruent to QR. And now, since this is a parallelogram, in a parallelogram we know that the opposite sides are congruent, so that makes PS congruent to QR. And the same thing would apply to the other pair of sides. Because PQ and RS are opposite one from the other, they should also be congruent, because in a parallelogram, opposite sides are congruent. So we end up with this, a figure with four sides that are congruent. Now let's look at the properties. A rhombus has all the properties of a parallelogram because by definition it is a parallelogram. So everything that we learn about the parallelogram also applies for this rhombus because it is a parallelogram. For example, opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. All those properties are true for the rhombus. But in addition to all those properties, we have two special properties that apply only specifically to a rhombus. Diagonals are perpendicular to each other. This does not happen in other figure but in a rhombus. So the diagonals are perpendicular to each other. So if we have diagonal PR like that, and diagonal QS those two diagonals are perpendicular to each other. So that means here we have right angles all over. So right angles all over the place here. And the next property that is specific for a rhombus, is that diagonals bisect the angles. Also, this happens only on a rhombus. So what happens here is that, for example, angle QPS, this angle here, is going to be bisected by diagonal PR, making these two angles here congruent. So we will end up with this angle here congruent to this one. The same thing happens with the other angle. QRS is going to be bisected by diagonal PR, but in a parallelogram, we know to start with that these big angles are congruent because they are opposite to each other, So that will make these two little angles here congruent to these ones here. So I'm going to mark in the same way that I marked the other ones. This piece is congruent to this piece. So actually we end up with these four angles being congruent to each other. And of course the same thing happens with the other angles in these corners. We will have that this angle is congruent to this angle because a diagonal in a rhombus bisect the angles, and the angles originally they are congruent, so these two angles would also be congruent. So one more time we have all these four angles congruent to each other. So those are the properties for a rhombus, in addition to all the properties of the parallelogram. And with this, we're going to solve our problems. Number one, it says quadrilateral EFGH is a rhombus. Find EF. So we need to find the length of segment EF. So we're dealing here with the sides of the rhombus. So we look at the property that is dealing with the sides of the rhombus, or the definition, whatever applies here. But actually there's no property about the size of the rhombus, you can see here. But we have from the definition that any two consecutive sides are congruent, and because it is a parallelogram, we end up with all four congruent sides. So we know that in a rhombus, all the sides are congruent. So here, I can actually write an equation using any two sides, especially these ones, which are the consecutive sides and therefore will be congruent. But we know that actually all of them are congruent to each other. So we would write our equation as, let's say, EH is equal to HG, which means 5n is equal to 3n plus 17. Solving the equation, we have 2n is equal to 17, and n would be equal to 8.5. So now that we know the value of the variable, we can apply here, which is a simpler one, and so we can find the length of EF, which would be the same as the length for all the sides. So EF would be equal to EH, for example, and therefore EF is equal to 5 multiplied by 8.5, and so EF is equal to 5 multiplied by 8.5, that is 42.5. And we're done with our first problem. We go next to number 2. Number 2, PQRS is a rhombus and the measure of angle P is 78 degrees. A, find the measure of angle PSQ. B, find the measure of angle RQS. C, find the measure of angle PQR. So the first thing is finding the measure of angle PSQ. PSQ is this angle that we see here. That's the angle that we're looking at for part A. So there are different ways of approaching this problem. We could consider this triangle that we have here on the top. And this triangle would be isosceles because we have a rhombus, and we know that in a rhombus, any two consecutive sides are congruent, like that, which makes this an isosceles triangle, and therefore the base angles, which is angle PSQ, would be equal to angle PQS, so the base angles would be congruent, so this one is also congruent to this other angle. So with that, and using the fact that we have a triangle, we can find the measure of angle PSQ. So the measure of angle PSQ would be equal to 180, which is the sum of the three interior angles of a triangle, minus 78, and then we will need to divide by 2 because we have two equal angles here. So 180 minus 78 divided by 2, it's 51 degrees. So we now have that this angle is 51 degrees. Part B, we have to find the measure of angle RQS. RQS is this one here. But we know that in a parallelogram, the opposite angles are congruent. So initially, this big angle here at vertex X would be equal to this big angle here at vertex Q. And not only that, we know that in a rhombus, the diagonal bisects the angles. So if this part is 51, and we know that this is also 51, this part should also be 51. So this is 51, and therefore this other one should also be 51, because in a rhombus the diagonal bisects the angles, and the first part, the first half is 51, so the other one should also be 51, and so it would be congruent and marking the same. Therefore, the answer for part B, the measure of angle RQS is 51 degrees. And then on part C, we have to find the measure angle PQR. PQR is the entire angle at vertex Q, and it's simply 51 plus 51, which is 102 degrees. So C, measure of angle PQR is 102 degrees. And with that, we are over with this problem. But you could have done this in a different way, because you could have considered that this is a parallelogram, and these two angles here add to 180, because any two consecutive angles add to 180 on a parallelogram, and therefore 180 minus 78 would have given you the entire angle, which is marked with yellow. But since this is a rhombus, we know that the diagonals bisect the angle, so this angle here would be equal to angle QSR, so that makes this part equal to that one. So after you subtract 180 minus 78, you should divide by 2, which is exactly the same procedure that we have over here. So any way that you do it, obviously you should get the same answer. Next one, number 3. It says, find the measures of the numbered angles in rhombus WXYZ. So one more time, it is a rhombus, and we have to find the measures of all these angles that are numbered. I would say the easiest thing to find would be the measure of angle 4, because we know that in a rhombus, the diagonals are perpendicular to each other, so there will be right angles here. So right angles all over the place, and therefore the measure of angle 4 would be 90 degrees. And then I can find the measure of angle 1, since I have here a triangle. We have 90 degrees here, 15 here. We just need to find the measure of angle 1. So the measure of angle 1 is equal to 180, because all the three angles in a triangle add to 180, minus the 90 degrees and the 15 degrees that we have on the top. So 180 minus 90 and the 15, that gives me 75 degrees. So I know that angle 1 is, the measure of angle 1 is 75 degrees. Then I could find the measure of angle 2, because we know that in a rhombus, which is a parallelogram, the angles are bisected by the diagonals. So that means if this half is 75, this other should be also 75, because these are halves of the angle XYZ. So it's simply 75 degrees. And finally, the measure of angle 3 Now here we have opposite angles, and in a parallelogram, opposite angles are congruent. So this one is congruent to this one. And because it is a rhombus, the angles are being bisected by the diagonal. So that means this one, which is half of this angle, should be equal to this one, which is half of the angle opposite from angle WXY, which are congruent to each other to start with. So the measure of angle 3 is 15 degrees. And that will be it for today. As always, check the website to see what is the homework.